Hey everyone, thanks for joining me again on my YouTube channel. This is Workshop Quick Takes. Last time in this series, we began fabricating a DIY 12 volt and USB power panel along with some audio interface for the back of our vehicle. That vehicle is a 2000 Jeep Cherokee, but this is applicable to a wide range of vehicles, cars, trucks, RVs, any kind of land vehicle that uses land vehicle style wiring. You can do this yourself, and as long as you fuse everything correctly back up at the battery, you should be pretty safe. Today, we're going to wrap up that build and install it, and if you've been waiting for that, then you're in luck. Come back with us to the workshop, and let's get cracking. Okay, so not looking too shabby at all. Drop those back down again. I can see I've got nice clear access holes behind there. Point of no return now. It definitely looks like Swiss cheese back here until I mount the plate in front. Alrighty, time passes and here we are. So I don't have everything mounted up yet. I've still got to do a lot of cleaning and painting on this sheet. But that there is going to mount like that. That's where that's going to go, but I'm first going to paint that black. Going to paint this black. And then still have to finish making the mounting frame that this is going to sit up on. Alright, I've buttoned this panel together just enough to be able to do a test fit. Still obviously needs a lot of prep and paint and so forth. It'll have to be mounted to these when we're good and ready. But I'll just use a couple of the scrap pieces for the initial test fit. Maybe even put our good old friend duct tape on the bottom. Just to kind of hold them together. So that one's going to end up being kind of like right there. Alright, pretty much like that, and you can already see about how much is going to show through on the back side. If I've done everything right so far, should be able to sit down onto that. And it does. So that's pretty much going to be its final mounting position. Let's see what that looks like from the back. There you go. So all of these ports will need to be accessible from the back side, even though some of them don't go all the way through. There's just no way to get to the terminals otherwise. Quick comment on what's going on here. I am interleaving layers of the 2K epoxy clear coat with a single stage flat black spray paint. By combining the two that way, the paint sets up almost as though it were a 2K product. Later, off camera, I then added more layers of the clear coat over the top. Okay, after multiple coats of paint and clear coat, including a two-part epoxy clear matte finish, here are both of our panels. This is the one that will house just the audio jacks and mount there. And this is the panel that holds everything else, including the plate with our power connectors for USB and 12 volt lighter socket. And then down here will be both of our speak-on connectors, which will provide up to 50 amp capacity. And down here will be our audio remote power on. That's pretty much the completed plate. The only thing left to do is start assembling it. Okay, next step, I'm going to try and put some of this edge trim around it. This has pre-applied adhesive inside of a rubberized vinyl rail, and what I want to do is wrap it, but in order to do that I'm going to have to custom cut it to go around some of these corners, so let's see how that works. Before continuing with mechanical assembly, take a look at your local hardware, not home improvement, but hardware stores such as Ace, Do It Best, or True Value for specialty hardware. You might have some fastener options available that can really spruce up your project. Well, not quite perfect, but there it is. I guess if I really wanted to, I could cut this section out and just put a square piece over it. And there we go, just a little bit of labeling. Power panel, fuses located in your battery, subwoofer, 20 amp max combined, 50 amp max combined, and P control. That of course is the remote turn on for the subwoofer amplifier. And then one of these will also be used to plug in the power supply to the amplifier. And then we're golden. Your three best tools for any automotive electrical work are a side cutters, a cycling wire stripper of some kind, and a full cycle crimp tool. Good quality full cycle crimp tools are available in the electrical aisle of home improvement stores these days, and they only cost about 20 bucks or so. Or you can get kits with interchangeable dies for a bit more online. So, with those in hand, along with a selection of wire, heat shrink materials, and crimp connectors, it was time to wire up this panel. The schematic illustration at left shows what we're trying to do. There are two audio amplifier power leads wired from the battery back to this panel. The first is metric size in copper-coated aluminum, but we worked out that it is roughly equal to 11 gauge and should be good for about 30 amps if necessary. We've got it fused at 20 amps for this application because it never hurts to oversize your wire a bit. The four devices on the 12-volt power and USB block receive 12-volt power from this lead, controlled by the lighted switch. The second is an 8-gauge copper power conductor, and it should be good for 50 amps, and we have it fused at 50 amps. This one provides power to the pair of high-output speak-on connectors, supplying 12-volt power to the subwoofer amplifier and to the auxiliary jack. Of course, a dual RCA and a much smaller wire are also running back here to provide amplifier line signal and the power control signal, respectively. But these are very low current connections and don't require anything special. We just blitzed through probably 40 minutes worth of electrical work in about 2 minutes. But before continuing on, since this project does require a lot of cutting, stripping, and termination to make all those little jumpers, let's just make a couple quick notes about tools. These here are a couple different varieties of side cutters. This one here is a fairly big, hefty one. This one's a small one. And over the years, most of us have done two things with these. We've cut wires. They obviously do that. But most of us have also cheated and use them to strip wires. That does kind of work. The problem is when you do that, usually you end up breaking some of the strands and weakening the wire here at the end. This works in a pinch, but it's not ideal, especially nobody doing any professional work should be doing it this way. Your next upgrade are objects like these. This one here is a typical type of a stripper cutter, where you have a cutter right there. Okay, so these here are marked by wire gauge size, and you just pick the correct one and do that. That's a much cleaner way of doing it. It still can rip at these wires a little bit, but usually it's pretty good. Another one is you find your marker on here. You're supposed to loosen this set screw and then bring it to the point where this thing will clamp only that far. And when it's clamped that far, then it will be sized for the wire and do the same thing. Your third option, which works on a number of smaller wires, I mean big fat wires no, but smaller wires yes, is this here. So if I use this, first of all, I can adjust this plastic thing in here to figure out how much wire I want stripped off. Once I've set that, bingo. And this can pull and tug at the strands a little bit, but this one is generally a very clean, repeatable way of stripping and cutting wires. So there's some options for stripping and cutting. Next up, let's look at crimping. These are both available from Harbor Freight. This is a brand that's available at multiple stores. I think I got this one at Home Depot. This is an assortment of heat shrink tubing, and there are other options available at Harbor Freight and other places as well, but Harbor Freight happens to have great prices on a large selection of heat shrink tubing. This is a general purpose terminal kit. These are your typical terminals. You crimp them, they are what they are. I mean, they're not super high quality, but they're good enough for most jobs. And then these are heat shrink connectors. You can get these both as butt connectors where you do two wires back to back. You can also get them as terminals. In this case, the Harbor Freight kit happens to be a fairly great value, even though it's not quite as high a quality as some of the ones I've gotten in other places. So these do work. I've noticed when I crimp them, I'm a little bit more likely to cut through the insulation, which defeats the purpose, because these are intended to be heat shrunk and then they're somewhat watertight if they're done right. Now, what to crimp with? That there is probably one of the most common tools you might have. It's available in almost every universal kit you can buy that includes a starter pack of terminations and a tool. This here is supposed to be a wire cutter. There's a crimper up here. This one here is supposed to be for larger terminals. And then a selection of wire strippers down here. These unfortunately loosen up rapidly over time, and then they don't work as well this way. They also don't make a reliable crimp up here. It doesn't matter whether they're this type that has like the little bow-shaped crimp, or whether the type that has the indentation to make an indented crimp. They just don't do it reliably. What you really want is a full cycle crimp tool. Now, there is a crimp cycle tool, not this one, available at Harbor Freight. I bought one once, and it was so badly constructed it would not reliably do even one crimp before it sort of just loosened up. I probably just got a bad one because they still sell it, and they probably wouldn't be doing that unless most people were having good luck with it. But this one was only a few dollars more at a home improvement store. Notice it says Klein Tools, not Harbor Freight brand or whatever. I would recommend on a full cycle crimp tool spending a little bit more in order to get a good quality one. You don't have to go, buy a $150 Burndy kit. This one here is good enough for the home hobbyist. What you need to make sure though is that it's rated for the types of terminals. Notice how it's red, blue, and yellow? That actually corresponds to the standard color coding of these terminals. So if you're doing a yellow terminal, and again, these are insulated terminal through rules, not uninsulated. That's why they're color coded by size. That one there, and I'll just go ahead and sacrifice one here in the name of science. Note that really tight crimp it made. If I had a number 10 or a number 12 wire in there, it's never coming out again, which is exactly what you want. Now that's all well and good. If all you're doing is a handful of insulated terminals here and there, this is fine. Although you'll notice there are a pair of screws holding this die in here, which means it's technically interchangeable. Now the store where I bought this doesn't have the interchangeable dies. But your next upgrade is a kit like this that you can buy online. This here is a tool that actually has interchangeable dies. And in this case, instead of a pair of screws, it's just spring-loaded for quick swapping. So what you do is you find the one you need. If you were doing red, blue, and yellow insulated ferrules like I just was, you'd use this one here. If you were using terminal connectors for like, say, Deutsch connectors or Delphi connectors that you use in a car, then you switch to this one here, or this one here, depending. And there's a couple other styles as well. But what you do then, this is a really nice universal tool to have because you take your dies, you press this in, slide it in, and then it locks. And the reason it's called a full cycle crimp tool is that you have to go all the way in and it will not release until a specified amount of torque has been reached on this connection up here. And then it ratchets and drops your connection back out. Now, not everybody needs a full interchangeable kit like this, unless, again, you're starting to get into connectors like Delphi connectors or Deutsch connectors, in which case these little pins in here do require some of these specialty dies to do. Then this is probably a good investment to consider. And this here is not a super high quality kit. I mean, this is just one you can buy off of like Amazon or eBay for 50 bucks, 60 bucks, 70 bucks, whatever it is. But nonetheless, it does the trick. And if you just need one particular specified type, then you can buy just that tool full custom. This one here has this little adjustable plastic guide on the back, but this one here is specifically designed to do the terminals in these sorts of connectors. And what this does is this takes a terminal. I mean, imagine my fingers are connected here, but once you crimp it, then it's connected like this so that the two tabs actually push down into the wires and doubly bind it like this. And that produces a really secure pin crimp that looks almost exactly like an OEM connector. So this is another option. Again, this is not a high quality tool. It is a dedicated tool. There's no way to change dies on this one. Okay, taking a quick look at how the electrical gets to the back there. Normally you might bring amplifier leads directly off the battery, but in this case there is an unused position, and I say unused on some of the newer Jeeps. I think on some of the older ones it was installed from the factory. There's a position there for a 100 mega fuse, which originally was associated with the starter, and then later they changed it to a fusible link. So I converted this position. I went ahead and put the mega fuse there, and then I'm using that as a tap point, both for the leads that go to the back as well as an auxiliary lighting fuse box I put in. So that provides a step of intermediate protection between here, which is tapped directly off the battery lead, over here, and then all the other accessories that I've wired in. And then each accessory in turn has its own sub fuse. That's an optional modification, and many vehicles will not give you this unless you add some more hardware, but since it was there, I figured out why not use it. Next step for the amplifier leads then is here's the 20 amp and the roughly 11 gauge cable right there. Kind of see the fuse on that one. And then the larger 8 gauge cable with its 50 amp right there. And then I do have these very thoroughly bundled and taped to protect against chafing, but that one chases kind of underneath the main wiring loom right there. Comes through there, and then passes into the cabin through an auxiliary wire grommet that I put in there. You can see there's actually a factory wire grommet going through right there. But there is an area right next to it you can just barely access with a drill if you first loosen up some of this wiring loom and get it out of the way, so you lift it up. And then you can kind of get in there with a stepper bit, drill through, and there's just a very small additional area of gap between the HVAC box. Of course, you can kind of see the fan located right down there. So that's roughly where the HVAC box starts. But there's just a small area you can get through right there, and you have just a thin gap inside that you can go down and get to the lower floor sill. So from that point, we actually do come into a narrow area that's back here. Once you remove all those pieces of plastic, you can get at it, and then come down next to the actual cabin fuse panel in here, and then under the sill, under this next sill. And I do have some footage here of when it was taken apart previously. And then back up under here, and then it comes out behind here where the power panel is. The power and audio leads have been tucked away for a while as other projects move forward on this vehicle, so the last step was to unbundle them and begin terminating. The 8 gauge lead was spliced into a Delphi style connector using an inline aluminum screw compression block. The disconnect is not essential to making your project work. So long as you can pull the master fuse at the battery, the circuit can be safely disconnected in the future. The next step was to finish terminating the power leads to the power panel, now permanently mounted into the rear quarter trim panel. Off camera, we then drilled a new ground connection into the body steel for the Speakon terminal's high current output. In theory, any ground point is as good as another, but in practice you need to think about spreading out high current returns, and consider that multiple returns grounded at the same point can transmit noise to each other. The other nearby ground point visible here was added for our trail lights in the rear, and is now shared with the 4-port socket assembly on the power panel. When putting a new ground in your vehicle, make sure to clean the paint down to bare steel so the terminations make maximum contact, and use a lock washer or a lock nut as part of the securing method. Okay, this looks a lot scarier than it actually is. What's going on here is, here's the number 8 coming in from the front. There's a wire loom up there. Here's number 8 coming in, and then wrapped up in here in a lot of silicone self-adhering tape is an inline aluminum splice block. You can buy these on the electrical aisle at a Home Depot or your hardware store, whatever. And the reason I did that is because I wanted to split it to a pair of conductors going into this Delphi, so this makes it disconnectable if I ever need to in the future. And then on the other side of this Delphi connector, it's splitting out to 4 12s, I think it was. They feed the 2 ports down here. So that's all that's going on with that, and then the 12s recombine as a ground and end up back here at the ground connection. And then the smaller one, meanwhile, it comes in, it hits the power switch, so everything goes through the power switch first, and then coming out of there, it jumpers. And so it goes over to the 12-volt port, which takes the most current, so that's the first one in the line with the number, I think that's 12 gauge again. And then from here, it jumpers over to the voltmeter down here and to the USB port pair over here. And then the grounds again off of those 4, because again there's one on the switch as well for the indicator light, recombine and then return back to the other ground connection you see up here. Yeah, okay, so these are, okay, actually let me correct that. These 2 are the ground connections for the Speakon ports. These 2 are ground connections coming off of this block here. And then the other one running back over here goes to some lights on the back of the vehicle. Then last of all, we've got power continuous coming in through here, and then it just kind of goes behind and through there. But in here it splices to that much heavier connector wire. And then up here is the audio jacks. And in a couple different places I just drilled a pair of holes about the width of the wire, and then tacked everything in place with a zip tie to make sure that it doesn't pop loose or pull out from the front. So again, it looks like a lot, but it's just a matter of keeping notes and routing everything correctly, and then that's what you get. A couple more details worth pointing out while we're in here. When you run wires, even for just a general cheap, quick and dirty amplifier, you'll save yourself a lot of trouble in the future if you run things through split loom tubing or some other kind of wire wrap, and then also tape things down where necessary, tie them together so that they travel in bundles rather than rattling individually. You can use cloth tape to prevent rattling in some cases. And then also, when you go around sharp edges, you can put edging pieces like that. Even the trim edging like we used around the perimeter of the panel can be slipped over sheet metal edges like that, just to make sure that something doesn't chafe against there later. Finally, just to wrap this up, there's our cords. This here is the audio amplifier one, so we have our audio cable, and then I have the power and the power control just combined into one loom here. Nice heavy wire until we get inside here for the power control, again for durability. That just goes up to a very old, like 15 or 20-year-old subwoofer I still had kicking around, so I figured why not. As you can see, it remains very, very flexible. And then here is our spare. So got a couple of connectors here, each one double wired like I originally intended to do. And then that there. Now this one I'm not going to plug in right now, obviously, unless I have a way of holding these apart, because if they short together, I'll blow my fuse up there. But we can go ahead and plug the amplifier back in so you can see that. That's audio. That's power from the speak on connector. Lock. And then this just clips down into there, which I don't think I can do one-handed, but you get the idea. And that's not actually stuck in there if you're curious. It does have a little bit of play on it, but the way that grommet turned out, I can push it back in there and it just kind of sits in there, and that works out fine for me. Hey everyone, thanks for joining me for that. Hopefully you found that interesting. Maybe you got inspired for your own project. Obviously this here is not an exact plan for how to build yours, but it gives you some ideas where to find parts, how to put them together, and what you can do with it afterwards. And that means it's time for you to get out there and start modifying your car or truck. Thanks for joining me today. See you again next time whenever we get back to this. Has anyone seen my phone?